So today I'm going to talk about computation with scientific numbers. Everybody knows why we have scientific numbers. If you're dealing with physics, sometimes nanoseconds is 0.000, and the mass of the Earth can be a million kilograms. That's why we use scientific numbers. So let's say we have 5 billion. Billion is 10 to the power of 9. If I was to write this as digit, it would be long. So scientific numbers are used to kind of shorten a shorter notation. So now I'll just show you a trick. Again, the techniques to solve scientific computation is something that's easy to learn and remember. That's only if you have big numbers. This is the way to do it. But of course, if you have small numbers, you can go the traditional way. So let's just give two examples where I use small exponents. Let's say 5 times 10 to the power of 2 times 3 times 10 to the power of 3. Okay, this seems pretty small. So I'm going to do it the scientific way first. Computation that we learn in class. We'll multiply the coefficients first. 5 times 3 is 15. Then we add the exponents. 3 plus 2 is 5. So that would give me 15 to the power times 10 to the power of 5. Again, this is not scientific notation until we reach one digit, then period. So 1.5 times 10 to the power of 6. Now, if I was to do it the other way, it would be 500 times 3,000, right? So 5 times 3 is 15. Then I add the zeros, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Then I have to write this as a scientific notation. So we count from here. 1, 2, 3, 4, 5, 6. So 1.5 times 10 to the power of 6. So we get the same answer. So what this means is that somebody was able to find a shorter way. So this is going to help us. This technique will help us when we have big numbers, big exponents to the power of 30, to the power of 60. We don't have to write it like this because this will take us forever and we might get into errors. But here all we have to realize, we have to multiply the constants and then we add the exponents of the other one. So, but there are different rules. So this is for multiplication. Now when it comes to division, you subtract the exponent, you just divide the constants in front of the tens. Now if I have, let's say 6 to make it simple, times 10 to the power 7 over 2 times 10 to the power negative 9. So let's say this. So I'm just going to focus on the constant. 6 divided by 2 is 3. And then I subtract. Always remember the 10 stays there. 7 minus negative 9 is going to be 16. So this would be your answer. Of course, in a real problem, you have decimals and you might have to fix it after. But the next one we're going to go to is the addition and the subtraction. So those two have the same rule, but they're different from multiplication and division. So let's say 7 times 10 to the power of 5 plus 3 times 10 to the power of 3. So as you can see, the exponent here, one exponent is 5, the other exponent is 3. Right, so 5 minus 3 is 2. So I always move the small exponent 10 to the power of 3. So I'm going to have to move the 10 to the power of 3 to 10 to the power of 5. So I have to move the 3